Hi guys, welcome to this LCD Keypad Shield tutorial in the series of building your own Arduino Shield project from start to finish. This is a practical tutorial aiming at teaching you everything you need to know to building any Arduino Shield of your choice. In this video, we're gonna build a fully working LCD Keypad Shield. We'll start from scratch explaining and simulating the circuit diagram in Proteus. Then we're gonna create a printed circuit board with Eagle, but any PC board design software can also be used. Then we're gonna generate the manufacturing files to manufacture our board with PCBWay or your favorite board house. And finally, we're gonna solder the component on our board and test the operation with a simple Arduino sketch. Are you ready? Let's get started. Here is our circuit diagram. Here on the left is our voltage divider. As we learned from the basic electronic component and their functions tutorial, a voltage divider is a simple circuit which turns a large voltage into a smaller one. To save digital pins on the Arduino board, multiple buttons can be connected to a single analog input. The way it works is really straightforward. Use a resistor network as a voltage dividers and then let each button feed a different voltage to the analog pin. Thus, by detecting the voltage, we can tell which button has been pressed. All our buttons will be connected to Arduino analog 0. We have labeled these buttons select, down, right, up, and left. A 2x16 character LCD display is used for this shield. The RS pin of the LCD is connected to Arduino Digital 12, the RW to ground, and the enable pin to Digital 11. The LCD data pins are connected to Arduino Digital pin 2 to 5. The potentiometer will control the contrast of the LCD. We're gonna have a reset button on our shield because the Arduino's button will be covered by the shield. We're gonna have two LEDs on our shield. One will be a power indicator and the other one will be connected to Arduino pin 13 to mirror the onboard pin 13, which will also be hidden by the shield. All LEDs will have current limiting resistors as learned in the previous tutorials. The sketch we're gonna use to test our board is really simple. We're just gonna display LCD Keypad Shield on the first line of the LCD. Then in our loop, we're just gonna read continuously the analog value on A0 and display the corresponding press button. If the analog value read is greater than 100 but less than 300, then we're gonna display the left button pressed. We're gonna also switch high the LED on pin 13 for 300 milliseconds. If this value is greater than 300 but less than 500, then we're gonna display up pressed. If it's greater than 500 but less than 700, we're gonna display right pressed. And if it's greater than 700 but less than 900, then we're gonna display down pressed. And if the value is greater than 900, then we're gonna display select pressed. And if the analog value is below 50, we're gonna display student companion on the second line of the LCD. Let us run LCD Keypad Shield. If I can press the up, it's gonna display up, right, down, left, select. And if nothing is pressed, then it's gonna display student companion on the second line. Next, we're gonna start creating the schematic of the board in Eagle. When you start Eagle, the control panel opens up. Gonna start a new project, file, new project. Here you can see our previous completed project. Let's call this one LCD Keypad Shield. Okay. Let us create a new schematic. Right click, new, schematic. Let's just save it. I always prefer to save before I can start working. Save as. We're gonna name our new schematic the same as our project, LCD Keypad Shield. Save. The first thing we're gonna do is to add some component. To do that, you can, under edit menu, you can click on add, or you can also click on the add icon. Eagle has an extensive number of built-in libraries. If a component you are looking for is not in the supplied libraries, you can add it yourself. The first component we're gonna add is the Arduino. We're gonna use the Arduino under the SparkFun board library. If you don't have this library in your Eagle software, please refer to our tutorial, Create Schematic with Eagle. You're gonna learn in details how to use the Eagle software to create a schematic and how to add new libraries to your Eagle installation. Arduino Uno, we're gonna use this Arduino Uno revision 3 Shield Basic. Click OK. Gonna place it here. To cancel the current action, you can either select a new action or click on the stop command. Next, we're gonna add the LCD. Let's see which one we're gonna use. Okay, definitely not this one. 16:2 LCD. Yeah, this one looks like the one we can use. Click OK. To rotate a component, you just have to press the right button of your mouse. And to place a component, you press the left button. We're gonna press it here. Click add to add a new component. The next component, we're gonna add our resistors. Under the RCL, this stands for resistor, capacitor, inductors. Let's see which one we can use. I've got the resistor with European symbols. Let's see which one you can use. You can see this is the resistor and this is the corresponding footprint. As you can see, all these footprints are different. The component can either be a surface mount or a through-hole component. These are through-hole component. And these are surface mount component. So you must always choose the correct ones. If you are not sure about the dimensions of your component footprint, always check your component data sheet to make sure that you are selecting the correct footprint. Otherwise, your component won't fit when you're gonna try to mount it on your board. Surface mount components are generally small. They allow for smaller PC board size, higher component density. They also allow for lower cost and faster production time. During assembly, surface mount technology component can be placed at a rate of thousands, even tenth of thousands of placement per hour, compared to less than 1,000 for through-hole mounting using automated manufacturing. The major drawback of surface mount technology is soldering. As components are smaller, mounting and soldering by hand is a great challenge. We have designed this board to be hand-built. That's why we only gonna use through-hole components because they are easier to solder and assemble by hand. So we're gonna select a through-hole component. This one looks like the one we can use. Click OK. Gonna rotate it, right click your button. Gonna need 9 resistors. 1, 2, 3, 4, 5. Okay. The next component, we're gonna need a potentiometer for our LCD contrast. Under the port, the European symbol again. Let's see which potentiometer we can use. These are the different footprint. Let's see which one we can use. Okay, this one looks that's the one we can use. Click OK. Next, we're gonna place our push buttons. Gonna search for switch. Okay, this is not what we are looking for. These are relays. These are deep switches. Not looking for this one. Okay, let's check this Omron because this is a switch manufacturer. Okay, this is exactly what we are looking for. Click OK. We're gonna need 6 switches. Right click to rotate. The next component we're gonna look for is our LED. Let's see, it's not this one. Under the LED folder, LED, got the 3mm. Okay, we're gonna use this 5mm LED. Click OK. Now we're gonna need some pin headers for the unused pins of the Arduino. Let's go to the pin header library. Pin header. We're gonna need a 5-position single. Okay, we're gonna use this one. We're gonna use this for the unused analog pins. Click OK. We're gonna need a 7-position single. We're gonna use this for unused digital pins. Okay. Next, we're gonna need a 2-position double. We're gonna use this for the unused special pins. Gonna place it here. Then we're gonna need a 5-position double. We're gonna use this for power. This can be used to power other components from the onboard 5V. The next thing, we're gonna need the power connection. Click Add. I'm gonna search for plus 5V. Okay, this supply 2, supply 1. We're gonna use this supply 1 symbol. Gonna need 7 power symbols. We're gonna also need the ground symbol. Gonna search for GND. Gonna use this first supply symbol. Okay, I'm gonna need 10 ground symbols. Now we have added all our components. We're gonna just start arranging them and connect them. To move a component, you can just click on the move icon, select the component you want to move, then you can move it to a new location. To connect a component, select the line icon, snap at the end of each component, click to turn, and then double click to end the termination. Gonna do the same. To delete a connection, click on the delete icon, delete. Gonna redo this connection, snap, double click to end the termination. Gonna connect this switch. Double click. Always use the junction icon to make sure that the wire are actually connecting. To rename a component, you can click on this icon, name, then you can enter a new name. Let's say the first switch, we're gonna rename it to select. To change the value of a component, you can click on this value icon, click on the component. This one is gonna be a 1K resistor. This one the same, 1K. You can also do the same by right click, properties, then you can enter a new name and you can also enter a new value. It's gonna be a 1K as well. To save some time, I'm gonna connect the rest of the component in fast motion. Right, we have done all the connections. There is some important thing that Eagle does, the electrical rule check or ERC. So click on ERC. You can see you've got a bunch of errors and warnings. Click on each error to see what Eagle thought might be an error. I'm gonna start with the first one. It says unconnected input. Basically, we're not gonna connect anything on D0, so we're just gonna ignore this. Click on approve. The next one on D1 is not also connected, so we're gonna approve it. The next one approve. The next one approve as well. Let's see the warnings. It says close but not unconnected. Yes, there is no connection here, even if it's closed. So I'm just gonna move this. There's nothing connected there. So I'm just gonna approve this one. It says missing junction in net 5. Okay, so basically it says that is not properly connected. Just delete it and redo it. Double click. Merge net segment into supply net 5. Yes. So I'm gonna approve that one as well. The next one, it says NC pin connected to ground. Yes, because it says not connected, but we are connecting to ground because I know for the backlight LCD we need to connect pin 16 to ground and pin 15 to current limiting resistor. So I'm just gonna approve this one as well. Pin connected, I'm gonna approve it as well. Net N2 overlaps pin. Let's move it around and see if it's properly connected. Can see it's not connected. This is very important to check, otherwise your PC board might not have all the required tracks and electrical connections. So I'm gonna move this, connect, double click. Now it's connected. Gonna approve it. You've seen how to fix them, so I'm just gonna fix the rest of the warnings in fast motion. Okay, we have fixed all the errors and warnings. Zoom to fit. This is our schematic. The next step is to lay out the circuit in board layout view. Gonna save the project. Now let us use this schematic we have just created and start building a circuit board in the board view. If you click on this icon here, generate switch to board, this will switch between the layout and the board view. So click. Because we don't have a layout yet, it's asking us this question: the LCD Keypad Shield board does not exist. Do you want to create it from the schematic? Of course, yes. Now we need to move all these components to this blank board. You can use the move tool. Select. Now rotate it. You can move the LCD as well. All these components are connected together with these yellow lines. These yellow lines are called a wire. They just represent electrical connections between components, but they are not copper traces yet. Add a button. Normally you can't put component on top of other component, but we know this Arduino board is not a component. This image is just a placeholder to place our pins and to align everything with the Arduino. So we're gonna put the component on top of this Arduino board as well. To save time, I'm gonna place the rest of the component in fast motion. We have placed all the components. Now we can add some more information on the silk screen. This information will be printed on top of the board. We're gonna add the title of the board. We're gonna also put some labels on these connectors so that the user will know their functions. Click on the text button, enter your text. I'm gonna write LCD Keypad Shield. Okay, you can see the selected layer is the top layer, but we're gonna print on the silk screen, so we're gonna select the top place layer. Okay, place, right click, properties, select 2, apply. Gonna add a label here, A1. This is gonna be analog 1. Can also be on top placed. We can also place some few text at the back of the board. So I'm gonna click on text. I'm gonna write LCD Keypad Shield. This time I'm gonna place it at the bottom. I'm gonna select the bottom placed. So this is basically how you can add text on your board. I'm gonna add the rest of the labels in fast motion. Okay, we have placed all our labels. Let us place some few mounting holes. Okay. Let me resize our board. The only thing remaining now is to route our A wires. First, let us set some net classes. Edit, net classes. If no net class is selected, then the A wire is going to use the default classes. So for the default classes, let's set the width to 12 and the drill to 10 mils. I'm going to create a new net class. For power, I'm going to name it power. I'm going to increase the width to 30 and the drill to 12. Okay. Now if I can click on the info button and click on this A wire, you can see it's 5 volts. So I'm going to change the net class to power. Now when we're going to route it, it's going to take the properties of this net class. So the ground as well, I'm going to set it to power. Okay. Now we are ready to route our board. You can either do it manually or you can use the auto router. We're going to use the auto. Click on auto router. I'm going to route it on the top and the bottom layer. The effort, okay, let us set it to high. Click continue. Click start. Okay, we finish routing. Usually you'll have to combine the auto router with the manual routing. We still have one A wire that need to be routed. Let me just move this trace to this side. To route manually, click on route. Select the layer. We're gonna route it on the top layer. Okay, now we need to check our board. Click on the design rule check. Clearance, we're gonna set the wires to 8 mil, the pad to 8 mil, the copper dimension 40 mil, the size, just gonna leave these values. Click check. It says we still have one A wire. Okay. This one can just ignore it. Proof. Clearance. This trace is too close to the pad, so I'm just gonna move it a bit. Yeah, it should be okay. Gonna approve it. The width. Increase the width to 0.3. Okay. This one I'm just gonna ignore it because it's gonna pass through this two pad. I'm gonna approve it. Okay. Now we are done with our PC board. The next step is to generate the Gerber files and send them to PCBWay to build our board. Great! We have reached the final stage of our PC board design. We now need to generate the Gerber files that we're gonna send to our manufacturing house to build our board. Gerber files contain the data about our PC board, where traces, pad holes are placed, their width, and so on. Because we've got different layers of the PC board, we'll generate different files for each layer. No matter which PC board design software you're gonna use, they should all produce standard Gerber files that should be understood by most PC board manufacturers. To generate our Gerber files, click on this icon to access the CAM processor. CAM is a short for computer-aided manufacturing. Eagle comes with a couple of default templates that you can use to generate your Gerber files. Click select local CAM jobs. We're gonna select this CFE GEB 274X. This is SparkFun job template. We're gonna use this one. Select. And that's all, guys. All we need to do is to click process job to generate our Gerber files. Process job. Then we're gonna select a folder where we're gonna save our files. We're gonna save it on the desktop. Let us create a new folder. LCD Gerber. Select. And that's all. That was really quick. Open the folder. These are our generated files. This is the drill file. The GBL is the bottom copper. The GBO is the bottom silk screen. The GBS is the bottom solder mask. The GTL is the top copper. The GTO, the top silk screen. And the GTS is the top solder mask. Before sending Gerber files for manufacturing, we're gonna check them one more time just to make sure that everything is correct to avoid some bad surprises. To do that, we're gonna use a Gerber viewer. We're gonna use the Gerber view. This is a free Gerber viewer that you can use. You can get one for free from gdaproject.org. File, we're gonna open our layers. LCD Gerber, gonna select all these files, open, and voila, this is our PC board. Now all you need to do is to analyze all your traces to make sure that everything is correct before you send your files to manufacturing, because once you send them and they've got mistakes, you're not gonna have any more time to fix your mistakes. So far everything looks good. I'm happy with the board. You can switch different layers on and off to analyze them. Alright, it's time now to send these files to be manufactured. We're gonna use our favorite PC board manufacturing company, PCBWay. This is a China-based manufacturer specializing in PC board prototyping, small volume production, and PC board assembly service, all under one roof with more than a decade of experience. They offer a quick turnaround PC board at a very budgetary price. For 10 PC board, they're gonna charge you $5. For 1 to 10 PC board assembly, they're gonna charge you $88. So to order from them is super easy. You can do everything online. All you need to do is specify the dimensions of your board. I know my board is 95 by 80. You can choose the quantity. We're gonna choose 10. It's gonna cost us $5. The layers, we're gonna leave the 2 layers. Click quote now. Now you need to specify some few parameters. We're gonna use a black solder mask. We love this color and this advantage of using PCBWay because they don't charge you extra for using these other standard solder mask colors, unlike other PC board manufacturing companies. The silk screen, we're gonna use a default white. Tick yes means you accept. Okay, I'm gonna tick yes. And that's all, guys. All we need to do is click calculate. They said for 3 to 4 days for 10 quantities gonna be $5, and if I want my board sooner, In 48 hours, it's gonna cost me 39 US dollar, and in 24 hours, it can cost me this 62. And you can select the shipping company that you're gonna use. You can see each shipping company is gonna have its own cost, so you can select a shipping company depending on your budget and how soon you want your board. So we're gonna select DHL, and our location is in South Africa, so it's gonna cost us 5 for the PC board, and the shipping is gonna be 55. Obviously this is gonna change depending on your location. Click add to cart. The next step is to upload our Gerber files, but if you design your PC board with Eagle, you can also import directly the Eagle board file, but in this case we're just gonna add the Gerber files because we've got them. Select the zipped folder and click submit order. And that's all, guys. My board will be reviewed, and after some few minutes I'm gonna get a feedback that my board have been reviewed. If everything is okay, then I'm gonna go and pay, and I'm gonna wait for my board.
This is the board that we have received after some few days. It roughly takes about 2 to 3 days to build up your board, and roughly 5 to 10 days for shipping, depending on where you live and the shipping company that you have selected. I ordered 10 PC board. They shipped 11, so I don't know whether this 11th one is a mistake or a bonus. Anyway, I can't really complain. I'm glad. I'm gonna now have 11 LCD Shield. I hope you'll be able to see with my camera. The PC board quality is really great. I love this black solder mask. I can see clearly all the markings on the silk screen. Even the small details can be read easily. Like Student Companion website address. I can even see the fabrication date engraved in the bottom copper layer. All the pads are good and plated. I should be able to solder the component without any problem. Even the material used is of good quality. I'm really impressed with PCBWay board quality. They did not compromise on quality with the low cost as some board houses do. They usually say you get what you paid for, but here I think it's a bargain. 10 PC board of good quality for only $5. What's remaining now is to solder all our components and test our shield. Are you ready? Here is our LCD Keypad Shield. Let's just plug it into the Arduino Uno. Just align the header pins and press. Everything looks great. All the components fit together. We use the correct component footprint. Let us connect the power to the Arduino USB port. There you go. The power indicator is on. Everything is looking good so far. The LCD backlight is also switched on. Let us upload our sample code to our board. Upload. Done uploading. We could see as well our LED from digital pin 13 flashing while we were uploading the code. The LCD displays Keypad Shield on the first line and Student Companion on the second line. Now we can test the keypad. By pressing each button, it will be displayed on the LCD. Left, down, right, up, select. You can also press the resend button. You can see the LED on pin 13 is also flashing. The board is working correctly. Let us test one more time. Up, select, right, down, left, and reset.
Thank you guys for watching this tutorial. I hope you enjoyed it. We have taken you through all the steps to design a fully working LCD keypad shield. We have also shown you where you can manufacture cheap quality PC board with PCBWay. If you want to learn more how to place an order with PCBWay, we have another video in this playlist explaining you all the steps. Thanks for watching. Don't forget to subscribe to this YouTube channel to receive more tutorials in the future. If you have any comment, you are welcome, and I will see you guys in the next tutorial. Thank you.